So today we are looking at, for the second half of our problems, we're looking at how to write the equation from the verbal description and then solve for the value of x. So for number 5, we are given -3 increased by a number x equals 4. So you may remember that we were practicing earlier in the week how to write an equation, or at the time it was an expression, right? No equal to sign. But how we were practicing how to translate these words into an actual algebraic equation. So what we're going to do here, before we can actually determine a value of x, we have to give ourselves an equation. So we're not always going to be given one, so that's why it's so important that we know how to translate between this verbal description and an algebraic equation. So let's just start like we always do, start on the left and work our way down. So -3 increased, so -3. We're going to just write what they told us to, right? -3, okay, -3. Increased by. Increased by is a key word for adding, right? So we know increased by means to add. So -3 increased by a number x. So remember we talked about whenever they do that, we let the variable x be a placeholder in our problem. So we want to write like a general formula or equation here. So -3 plus increased by a number x, which we just use the variable x, equals, and then they tell us what it equals. So equals 14. So this is our correct translation of the sentence -3 increased by some value of x equals 14. So not only did we did the first part, right? We wrote an equation, has the equal to sign and everything, from that verbal description. But now we need to determine the value of x. So the value of x, we find that from solving the equations. We are going to isolate the variable, doing the opposite operation of whatever we see, but keeping in mind that we always move anything that's added or subtracted to the x term first. So I'm trying to get this x by itself, but I've got this -3 going on. We want to think about how can we make this -3 go to 0. So this is the same thing, right? Some of you might be thinking it. This is the same as x minus 3, positive x minus 3 equals 14. Same thing. It's just that when we transfer it from here, they started with the -3, but we could flip it and that would be totally fine. This is just like what we did up here, but we can work with this from this stage. I just wanted to remind you, these are the same, because what I'm going to tell you to do might feel a little weird when it's written with the -3 in front. But remember, guys, our goal is to isolate x, to get x by itself, get the variable alone. So I'm going to do whatever it takes so that whatever's around it goes away. So a -3, or taking away 3, the opposite of that, of subtracting 3 or taking away 3, is to give 3, is to add 3. And because it's an equation, what I do on one side of the equal to sign, I need to do on the other. So it'd be the same thing here if I wanted to kind of follow along with this one. This would go to 0, just like this is going to go to 0. -3 plus 3, that zeroes out for us, and that's what we're looking for. Leaving only the positive x. You don't have to write a plus x, it's positive x. Think of it as like that's telling you the sign now that the 3's are gone. And then I simplify. 14 plus 3 gives me 17. And so that's the value of x. If I took a number, if I had a -3 and I increased it by 17, I would get 14. And so if you finish this one, just to show that these are equivalent, you get 17 either way, but following the way that this one is written, we need to be able to handle these problems that lead with a negative number in the front. But just to show that it is the same, but we just have to, we're still doing the opposite of what we see. So if I have a negative or taking away 3, do the opposite, which would be adding. Now for number 6, we have rectangle ABCD and then no picture. I don't even read on, guys. I stop. I'm like, all right, they didn't give me my rectangle, so I guess I have to draw it. So there's my rectangle. And they tell us that it has a length of 2x minus 1. And remember, you can't mess it up. Just pick a side, pick one that's going to be length and one that's going to be width. And a width of 3, so I'm going to put my 3 here. Uh-oh, the area. The area is 57 units. Find the value of x. All right, so I want the value of x. I need to know what this is. Well, using what we know about rectangles, the opposite sides are equal. So I'm going to drag over what I labeled, right? So I know that their opposite sides are equal. So if it was perimeter, then I would be using that add up all the sides thing. But for area, it's a little different because area, if you'll will recall, the formula, it's not an add up all the sides scenario. The formula is length times width. So we need that formula because the way that we're going to have to solve for x is going to require us to make use of that area. So I know that I get, this is going to be some substitution. If the area is 57, then I can replace the area in the formula with what I know it's equal to. So for this rectangle, it has an area of 57. And then now, length times width, or we could put the length, we can write the length here, we can put the width behind it, or vice versa. If we wanted to look more like we are distributing, then we might want to put the 3 in the front, but it really shouldn't matter. So I'm going to show you, kind of why. But if I plug in my length times my width, the way that they gave it to me, this 3 is being multiplied times the entire front term, times that entire length. So this is what it would look like to have a distribution problem, but the 3 is behind it, or what you're distributing is behind the parentheses here. But it's still the same concept, right? This 3 needs to multiply times all of the parentheses, times the total length, not just one part of it. So for this, when we multiply 3 times the 2x, we're going to get 6x. And we multiply 3 times a negative 1, and that gives us a negative 3. And then our area, we just bring it down because we haven't even dealt with that yet. Now we are kind of like where we were up here, back to example 3. Now we've solved for x because that's what our question is asking us to do, to find the value of x. So we keep in mind that x needs to be solved for. I'm going to move whatever's added or subtracted to x first. So I'm going to add 3 because right now I'm taking away 3. The opposite of subtracting is to add, so that's going to cancel. What you're going to see on the left side here is that we need to combine that constant, the constants, 57 plus 3. I'm sorry to do this. I'm going to have to come over here, my challenges of the large handwriting. Some of y'all feel my pain. But 57 plus the 3 is going to bring us over here. And then we're left with the 6x. And then I one more time, because I still have that 6 in front, I have to ask myself, how do I get the x alone? Well, I do the opposite of what I see here, which is multiplying. So I undo that multiplying by dividing. And whatever I do with an equation, on one side, I balance it by doing the same thing on the other. So 60 divided by 6 gives us 10. And that is our solution. And of course we could check it, right? We could take 10 and plug it in here to see what that dimension comes out to be, and then multiply length times width to confirm that our area is 57. We will do that sometimes in class, but for sake of time right now, I'm not going to show all of that. But I'm happy to go through that with you so you can see what that check looks like. As our last problem, we are asked simply, is x equals 3 a solution to the equation negative 4x plus 20 equals 8? A couple of ways you could handle this, right? We can solve for x. I'm going to solve for x because that's what we're practicing, and I want to make sure that you see as many examples as possible. So here's us solving for x and trying to see, do we get 3? So I'm going to try to get x alone. I'm going to do the opposite of whatever I see happening to x, starting with anything added or subtracted. So if I have plus 20, I know the opposite of adding 20 is to subtract 20. I know that that's going to zero out for me. On the left side, I'm left with that negative 4x. That just comes down the way it is. And then I'm going to use a calculator, guys. Use the calculator. 8 minus 20 is going to give you negative 12. You're taking away more than you had, but use the calculator. 8 minus 20, negative 12. One last step, ask ourselves, how do I get x alone? Well, I do the opposite of what I see. So I'm multiplying x times a negative 4, which means I need to divide by negative 4 on both sides. That's going to reduce out. And then I'm going to put this in the calculator. And I'm going to see that I do get a positive 3. So yes, my answer would be yes, 3 is a solution. You may have been thinking, well, can I just plug it in? Sure. You could absolutely replace x with what they're asking to see, hey, is that going to check out? Is that going to give me 8? When we do that, negative 4 times 3 is a negative 12 plus 20. Negative 12 plus 20 in the calculator is a positive 8. And so that's an alternative. That's a check. But I want you to be able to solve this equation for x, as well as know that you can plug in solutions to check and see, to confirm if those really are your answers or not. And again, use that calculator a whole lot to make sure that we're not making any silly mistakes with the mental math, and especially with those negative signs. No shame in using the calculator.